Alrighty, for this problem we want to convert this equation to standard form and then classify it and then graph through a little quick sketch of what this would actually look like. So we it's kind of just a test of how well you are, how well you can solve the square, pretty much, right? So let's try to get it in a form that looks a lot more presentable and we understand what it actually looks like. Right, so I like to write everything out a little neater, right? So that I know what I actually need to add or subtract to both sides so that I can complete the square. Makes it a lot easier. Right in here I'm just rewriting this in a form that looks a lot more, a lot easier to see. Right, minus x is equal to negative minus 20. And this is the same exact thing. I just kind of put spaces there to know what I have to add or subtract, right? And pretty much what I want to do is complete the square, right? By adding adding something to both sides, and the actual completing the square here. So here, if I were to add 16 to the left, right? If I were to add 16 here and then add um, 4 here, right? We would get something that looks a lot neater. We can actually complete the square here, right? I should assume you know how to do that, right? So we can just skip right to actual completed square. So you get 4 times y minus 2 squared, right? Plus, and then completing this square here, we will get z minus 2, right? Z minus 2 squared, right? And then minus x, of course. Minus x is equal to 0, right? Because here we have, right, I should actually show you, so minus 20, and then we added 16 to this side, and then we added another 4, right, to the left, so we have to add it to the right, and this just goes to 0, right? So that just goes to 0, right? And now we have something that looks like an equation that we probably should be a little familiar with, at least at this point. Right, so that's 4y minus 2 squared plus z minus 2 squared, right? And what this takes the shape of is an elliptic paraboloid. I'll write it down. This is an elliptical paraboloid. Hope I spelled this right. Paraboloid, maybe? Follow that. And now we want to give a quick sketch. Right? We want to sketch out a little bit what this parabola would look like, right? And let's see, something like that. This would be our x, our y, and our z. And note where this elliptic paraboloid is being oriented. It's being oriented about the x-axis. So our elliptic paraboloid is going to look something similar to a parabola around the x-axis. So it's gonna have something like that, right? It's a parabola around the x-axis, right? And it's also being shifted by 2. This is just a general rough sketch. Really, it's actually being shifted by 2, and 2 here and 2 there. If you want to get really accurate with your sketch, but that's just a general sketch of what this looks like, right? So the second problem, we have find the parametric and symmetric equation of the line passing through the point 1, 1, 2 and perpendicular to I plus j and j plus k, right? So given, we know that we have the formula for equation of a line, and that's our the equation of the line is equal to r naught plus t times a vector. So r naught being a point, an initial point, and this vector being a vector on the line, right? So we want to have a vector, right? And we want that vector to be perpendicular to I plus j and j plus k. And the way we find a perpendicular vector between two vectors is by taking their cross products, right? So then our v, we know our v here would be the cross product of I plus j, right, and j plus k, right? And this r naught here would be equal to the our initial point. So then it'd be 1, 1, 2. Okay? And right, so now we know what our b and we know what our naught is, so we can go ahead and start plugging in. Our vector is equal to 1, comma 2, comma 1, comma 1, comma 2, right? And then plus t times our vector. Here, the cross product of I plus j and j plus k, it's, if you can do it in your head, like I could, it's just I minus j plus k, or equivalent to 1 minus 1, 1. For time saving purposes, if you don't believe me, you can go do the cross product by yourself, and you'll get to the same conclusion. And then here, distributing the t into that, and then adding this, we get that the vector r, the equation of the line, is actually equal to, right, 1, or t plus 1, however you like, t plus 1, 1 minus t, and t plus 2. T plus 2. Again, this is just me distributing the t through, and then adding the components together to get this final r. Right, but we want it in parametric form, so we just set their components equal to their respective values. So x is going to be equal to 2 plus 1, or t plus 1, sorry. Y is going to be equal to 1 minus t, and z is going to be equal to t plus 2, right? So that'd be our parametric form, right? This is parametric, and this is going to be symmetric, right? And all we do here is solve for symmetric. We solve for t, right? So then, right, so we have t, so we have t is equal to x minus 1, right, divided by 1, which is the same thing, which is also equal to solving for t here, which is also equal to y minus 1, again divided by 1, but really it's just 1, and this is also equal to this again is equal to z minus 2 over 1. Right? So we we'll get that. That would be our symmetric form. Hope that helped. Let's just make sure, double check the work, just to make sure I'm not showing anything wrong. So yeah, okay. This should be this is a minus 1 actually. So this, good thing I checked my work. Right, this would actually indeed be equal to 1 minus y. Right, solving for t here. We move the 1 over 1 minus y, and then we divide by the negative 1. Either way, it really all depends on how you like to solve it. Be a negative 1 down here, but that's the general answer.